Then moving on to the next one, we talk about one particular phenomena called as capillarity. We're talking about the phenomena of capillarity. Capillarity means the rise and fall of a liquid. In any particular glass tube, if at all you are taking, the rise and fall of a liquid in that one, that is what you call it as capillarity. Now for example, suppose that you are taking a beaker like this. You are taking a beaker. Now this particular beaker, it is consisting of water. The beaker, it is consisting of water. The beaker is filled with water to a certain level. At the same time, in this particular beaker, you are placing a capillary tube. A capillary tube is a very fine glass tube, which almost looks like a straw that we use for drinking a coconut water or cool drink, something like that, right? So in this particular capillary tube, now the moment you are placing a capillary tube in a beaker which is consisting of water, the water level which is present in the capillary tube starts slowly increasing. The moment you are placing a capillary tube in a beaker which is consisting of water, the water which is present in the capillary tube starts increasing. At the same time, the top surface of the liquid which is present in the capillary tube will be something like this. It's curved. And this particular top surface is what you call it as meniscus, right? The shape of the meniscus is what you call it as the concave surface or else a concave shape. So whenever a capillary tube is placed in a beaker consisting of water, the water which is present in the capillary tube starts slowly increasing, but at the same time the level of liquid in the capillary tube will be more with respect to surroundings. At the same time, this particular top surface, this is what we call it as a meniscus. The meniscus will have got a concave surface, right? At the same time, on the contrary, if you take the case of, instead of water, you are taking another liquid. You take another beaker of the same size. So in that particular beaker, this is filled with mercury here. In the first beaker, you are filling with water in the first case, whereas in the second beaker, you are taking the case of mercury. So whenever you are placing a particular capillary tube in a beaker which is consisting of mercury, then in that particular case, the level of mercury in this particular capillary tube will be less with respect to the surroundings. Here in this particular case, the level of water has increased with respect to surroundings. But here, if you compare here, the level of mercury in the capillary tube will be less with respect to surroundings. At the same time, the surface will be having a surface shape like this. It will be having a shape like this, and this particular shape is what you call it as a convex shape. This is what you're having, a convex surface. So whenever a capillary tube is placed in a beaker consisting of mercury, the level of the liquid will be less than surroundings. At the same time, this particular surface, the meniscus, will be having a convex surface. In the case of water, the meniscus will be having concave surface. Now what is the reason? Why in one case, in the case of water, it is increasing? Why in the case of mercury, the level is decreasing? Now the reason for this is, you call that one as the angle of contact. Angle between the liquid, whether it is water or whether it is mercury, the angle between the liquid and the glass surface, that is what you are calling it as the angle of contact. In case of water, the angle of contact is only 8 degrees. In case of water, the angle of contact is 8 degrees. In case of mercury, the angle of contact is something around 135 degrees, like that. 135 degrees. So here it is 8 degrees, and there in that particular case it is 135. Since the angle of contact is around 135 degrees, mercury will not stick to glass. Mercury will not stick to glass. At the same time, it loses its capacity to rise upwards. Right? That is the reason why the level of mercury in the capillary tube is less with respect to surroundings. Now, this is one of the reasons why mercury is used in the case of thermometers. In the case of thermometers, we are not using water, we are using only mercury. Right? Water is also existing in the liquid state. Water will also expand on heating, but you are not preferring water, you are just taking only mercury. One of the reasons is that mercury will not stick to glass, but wherein water will stick to glass. Water will stick to glass. Suppose that if you take a glass of water and throw on any surface, on any particular wall, 99% of the water will come down immediately, but wherein a small amount of water will start moving, will start dripping downwards, drop by drop, drop by drop. Right? Indicating that water has got sticky nature. But suppose that if at all you are throwing mercury on any surface, the complete mercury will come down. Indicating that mercury will not stick to any particular surface. Then, when you're talking about the case of applications of capillarity. Now, capillarity has got number of applications in our day-to-day life. The first and foremost thing, absorption of water by the roots of a plant. Absorption of water by the roots of a plant. At the same time, absorption of water, you have got number of things. Absorption of water by tissue paper, or else you can say blotting paper. Tissue paper, blotting paper. At the same time, the case of sponge. The absorption of water by all these particular substances is based on one particular thing called as capillarity. At the same time, the working of kerosene stove. Once upon a time we used to have the kerosene stove, right? To be more precise and to be more clear, the working of the wick of kerosene stove. So whenever you open that particular kerosene stove, or as the lantern, you will be finding a cloth which is made of cotton. That particular cloth which is made of cotton, that is what you call it as wick. Right? The cloth which is made of wick, which we are using in the case of your kerosene stove or kerosene lanterns, that is what you are calling it as wick. At the same time, right? Candle, the working of candle. Right? At the same time, the circulation of blood in human body. The circulation of blood in human body through arteries and veins is again because of one particular phenomena called as capillarity. Then at the same time, the formation of oasis in deserts. Right? A place where water appears, water is really present in desert, that particular place is what you call it as oasis. Right? The formation of oasis in deserts is because of capillarity. The place where water appears to be present, that is what you call it as mirages. The place where water appears to be present, but water is not physically present here. Water is present here. So the place where water is present, that is what you call it as oasis. The formation of oasis is because of capillarity. At the same time, the working of fountain pen. I hope you know what is fountain pen, right? Ink pen, right? So the working of ink pen or as the working of fountain pen is based on one particular thing called as capillarity. Right? Then we'll move on to the next one. Right? Then moving on to the next topic. Atmospheric pressure. Now we all know that air has certain amount of weight. Air has weight, at the same time air exerts pressure. Air has weight and air exerts pressure. The pressure that is exerted by air, the pressure that is exerted by atmosphere on us, that is what you are calling it as atmospheric pressure. So when you're talking about the case of atmospheric pressure, now we talk about one, we can give number of examples for this. Now suppose that when you are moving on, or else when you are walking on, a road, you can do that particular activity very comfortably. The moment you're running, you start breathing heavily. The moment you're running or the moment you're jogging or else sprinting, you start breathing heavily. The reason for breathing heavily is that the pressure that is building up inside the body is more when compared to the pressure that is exerted by air on us. That is the reason why we start breathing heavily. That is the reason why we start breathing heavily. Now this particular term called as atmospheric pressure, the value of atmospheric pressure is given by 76 centimeters of mercury. Atmospheric pressure is always measured in terms of mercury. 76 centimeters of mercury. So in order to measure this particular atmospheric pressure, we use a device called as, atmospheric pressure is measured with the help of a device called as barometer. Now this particular barometer, we have got two different cases. One is the mercury barometer. The other one aneroid barometer. Mercury as well as aneroid barometer. Now what is this case of your mercury barometer? So when you're talking about the case of mercury barometer, first you take a glass tube which is of 1 meter length. A glass tube which is of 1 meter length. At the same time, the diameter of this particular glass tube is something around 1 centimeter. The diameter is 1 centimeter and the length of the glass tube is 1 meter. This particular glass tube is closed at one end, open at one end, closed at one end and open at one end. And the glass tube is completely filled with mercury. This particular glass tube is completely filled with mercury. From the top to the bottom, it is filled with mercury. And then the glass tube is placed in a beaker or else a small bowl which is consisting of mercury again. First you are taking a glass tube which is having a length of 1 meter and a diameter of 1 centimeter. The glass tube is completely filled with mercury. Now this particular glass tube which is open at one end and closed at one end is inverted. Suppose something like this. This is the open end, this is the closed end. Now you invert this particular tube like this and place it in the bowl. The moment you are placing this particular glass tube in a beaker which is consisting of mercury, then in that particular case, the level of mercury which is present in the glass tube starts decreasing. Right? Initially, the glass tube is completely filled with mercury up to this particular point. The moment you are inverting it, the level of mercury in the glass tube starts coming down, starts decreasing, and it stops at one particular point. So here in this particular case, the mercury is like this. The mercury is present only up to one particular point. So the mercury decreases and stops at a particular value of 76 centimeters. So since we are measuring this one, since we are using mercury in this, we call this one as 76 centimeters of mercury. So atmospheric pressure is always measured in terms of 76 centimeters of Hg, or else you can even write 760 mm of Hg. Right? Now, if at all the level of mercury in the glass tube starts decreasing suddenly, if at all the level decreases suddenly, right? If at all the level of mercury in a particular barometer starts decreasing suddenly, then in that particular case it indicates or predicts the formation of cyclone. If at all the level of mercury in this particular barometer is decreasing suddenly in the sense it is decreasing from 76 to 73 or 74 centimeters of Hg. If it is decreasing suddenly, it indicates or predicts the formation of cyclone. The cyclone may be forming in the case of your Bay of Bengal, or else maybe in the case of your Arabian Sea, wherever it is, right? Or else, suppose that if the level of mercury decreases, even in this case also it is decreasing, but if the level of mercury decreases gradually or else slowly, the first case, the level of mercury is decreasing suddenly, a sudden decrease from 76 to 74 or 73 or 72, depending upon the intensity of this particular cyclone. Cyclone is always a low pressure area that is built up in a sea or ocean. That is what you call it as a cyclone. Right? Now, depending upon that particular cyclone, intensity of the cyclone, the level of mercury decreases maybe from 76 to 74 suddenly, or else it may decrease from 76 to 72 centimeters suddenly. Right? But whatever it is, it indicates the formation of cyclone. Instead of that one, if the level of mercury in the barometer is decreasing gradually, then it predicts rainfall. Ordinary rainfall. Right? A rainfall that will last only for around 20 minutes or 30 minutes, or as maybe a couple of hours. So in that particular case, the level of mercury decreases gradually. Then after that one, first it is decreasing from where? Decreasing suddenly, maybe from 76 to 72 or else 73, or else decreasing gradually or slowly from 76 to 75 centimeters. After decrease, if at all the level of mercury increases, in the first two cases it is decreasing. If the level of mercury increases, it indicates the restoration of normal conditions. If at all the level of mercury increases, it indicates the restoration of normal conditions. A simple, quiet, sunny day. A simple, quiet, bright and sunny day, that is indicated by the increase in the level of mercury in the barometer from 74 to 76 or 72, 76, that indicates the restoration of normal conditions. And this particular value of atmospheric pressure of around 76 centimeters of Hg is at normal sea level. The value of 76 centimeters of Hg, this particular value is present at normal sea level. Now suppose that, for example, you are taking three different places, right? I am taking the case of Vizag, Visakhapatnam, or else Mumbai, or else Chennai. At the same time, I am taking one more place, Hyderabad. At the same time, I am taking one more place, Shimla. Three different places. Now, this particular place which you are calling it as Vizag, this is present at the sea level. The moment you are coming from Vizag to Hyderabad, you are moving down to a plateau region. Hyderabad basically it's a plateau region, Deccan Plateau. At the same time, the moment you are moving from Hyderabad to Shimla, Shimla is a hilly region. So there in that particular case, the height of a particular place is continuously increasing. When you are moving from Vizag to Hyderabad to Shimla, there in that particular case, the height of a particular place is increasing. In Vizag, atmospheric pressure 76. As you are moving from Vizag to Hyderabad, right, height is increasing. With respect to height, atmospheric pressure value decreases. With respect to height, atmospheric pressure value decreases. When you further move down from Hyderabad to Shimla, then in that particular case, the atmospheric pressure value still further decreases. As the height of a particular place increases, atmospheric pressure at that particular place just keeps on decreasing. So with decrease of atmospheric pressure, the level of oxygen also decreases. That is the reason why it is quite difficult. It's not that easy to walk or jog in a particular hilly area. Walking is difficult, right? Breathing is difficult. Number of reasons, right? Suppose that if at all today you are playing in one particular place, today you are in South India, and by tomorrow morning if at all you are planning to climb Mount Everest or else K2 or else Mount Goodwin, then in that particular case your body will not be able to adjust to the conditions of that particular place. As a result of which, first thing that will take place is nose bleeding. Blood will start coming out from nose, or else maybe from ears, then finally from mouth, and then that leads to the death of a particular person. Why it is happening so? Because at that particular place, at this particular place which you are calling it as Mount Everest or K2 or Mount Goodwin, at that particular place the atmospheric pressure value is low at that particular place. Wherein in the case of your Vizag or Hyderabad, atmospheric pressure is 76 or something around 75 or 75.5. So our body is adjusted to the climatic conditions of this particular place. The moment you go to K2 or Mount Goodwin, body will not get adjusted. Lungs will not get adjusted to the oxygen levels of that particular place. That is the reason why first nose bleeding will start taking place. Reason is that the pressure that is inside the body is more when compared to atmospheric pressure. So in a place like Vizag, in a place like Hyderabad, atmospheric pressure, body pressure, both are balanced. Atmospheric pressure, body pressure, both are balanced. So you are able to do our activities without any problem. The moment you go down to Mount Everest or K2 or Mount Goodwin, at that particular place, atmospheric pressure is low, body pressure is high, as a result of which the pressure in the body has to come out. So the pressure in the body is coming out in the form of nose bleeding. The pressure in the body is coming out in the form of nose bleeding, or else the blood from the ears, or else maybe from mouth, leading to death of a particular person. So usually nose bleeding takes place at high altitudes. Nose bleeding takes place at high altitudes because of low atmospheric pressure. Nose bleeding takes place at high altitudes because of low atmospheric pressure. At the same time, right, you talk about the hill stations, right? So when talking about the case of hill stations, you're talking about one particular thing called as cooking. So in the hilly region, or else in the hill stations, at elevated place, to be more simple, to be more precise, to be more clear, we use the word cooking, right? At elevated places, cooking is quite difficult. At elevated places, cooking is quite difficult. It takes more amount of time. Cooking will take place more amount of time at elevated places. The reason, what is the reason for that? Right? So in elevated places like your Shimla or else Ooty or Kodaikanal, that particular place, cooking is taking more time. That is the reason why the people who are residing in that particular area, definitely they have to use this particular thing which are calling it as pressure cooker. Right? Why? To minimize the time of cooking. To minimize the time of the cooking. Why cooking is taking place? Why cooking is taking more time? Because of low atmospheric pressure. So at elevated places, cooking is taking more time because of low atmospheric pressure. At elevated places, cooking will take more amount of time because of low atmospheric pressure. So to reduce the time of the cooking, we need to use pressure cooker. Right? So what is the reason? What is the relation between cooking and low atmospheric pressure? What is the relation between cooking and low atmospheric pressure? As the atmospheric pressure decreases, at that particular point, the boiling point of water also decreases. Now we all know that as the atmospheric pressure decreases, temperature is also decreasing. Right? At the same time, as atmospheric pressure is decreasing, the boiling point of water reduces. Now we all know that the boiling point of water is 100 degrees centigrade. But generally at elevated places like your Kodaikanal or Ooty or Shimla, the boiling point of water is something around 96 or 97 degrees centigrade. So the maximum boiling point of water at high places, at hill stations, there in that particular case, it will be something around 97 or 98 degrees centigrade, which means water will not boil to the maximum point. Actually, water is supposed to boil at what? 100 degrees centigrade. But here in this particular case, water will never achieve its boiling point because of low atmospheric pressure. Now, since water is not reaching to its boiling point, whenever you are trying to cook potatoes, or else whenever you are trying to cook rice, or any particular items, there in that particular case it takes more amount of time because of temperature, of water. Water is not achieving its maximum boiling point. That is the reason why at elevated places generally people they prefer pressure cooker. Why? To reduce the cooking time. Because at that particular place, atmospheric pressure of a particular place is very much low. As atmospheric pressure decreases, the boiling point of water is also getting reduced. That is the reason why at elevated places generally pressure cookers are being used. Right? Then moving on to the next one. Before moving on to the next one, I'll just show you some slides regarding this. This is the case. So when talking about the case of barometer, what is barometer? It is used to measure atmospheric pressure, right? And this particular vacuum, the vacuum that is present here, Now this particular vacuum that is present here, this particular vacuum is known as Torricelli vacuum. It is known as Torricelli vacuum. Now this is a beaker in which you are placing a pipe glass tube which is open at one end, closed at one end. The moment you are inversing, the level of mercury is coming down. The level of mercury will come down, will decrease and stop at one particular value. That particular value is something what you are calling it as 76. And the region above this one, this particular vacuum, this is what you call it as Torricelli vacuum. And this particular atmospheric pressure value, it varies from place to place and it varies from time to time. It varies from place to place. The force that is exerted, the pressure that is exerted by air, that is what you call it as atmospheric pressure. That is what you call it as atmospheric pressure. Then, moving on to the next one. That is the case of surface tension. So when talking about the case of surface tension, now this particular thing called as surface tension, it is a force. Basically it is a force that is acting per unit length. Surface tension, we say that it is a force that is acting per unit length, and because of this particular force, which are calling it as surface tension, the mercury drops, water drops or oil drops, they always try to have the minimum area of cross section. Now the moment, suppose that from this particular place you are dropping some oil, the moment this particular oil falls onto the floor, wherever it falls, maybe at this particular point or maybe at this point or maybe at this point or maybe here, any particular point, the moment this particular oil drop falls on the floor, each and every drop will try to have the minimum cross-sectional area, something like this. So you might have observed this in n number of times whenever you have observed the case of your raindrops, water drops or oil drops. Each and every drop will always have a cross-sectional area, which each and every drop will try to have a spherical shape. Spherical shape, because this particular thing, it tries to fall like this. It's trying to have the minimum cross-sectional area. That particular force which is trying to have the minimum cross-sectional area is what you call it as surface tension. So when you're talking about the case of surface tension, you need to talk about two different types of forces. One is the cohesive force, other one is adhesive force. Cohesive as well as adhesive forces. Now this particular force called as cohesive, it tries to act between two similar molecules. At the same time, adhesive force is the one which is trying to act between two different surfaces, right? Two different surfaces. That is what you call it as adhesive forces. Cohesive forces between two similar molecules. Now because of this particular cohesive forces and adhesive forces, we talk about one particular thing called as surface tension. Now when talking about the phenomena of surface tension, right, we come across number of applications. Surface tension has got number of applications in our day-to-day life, right? We say that oil drop, a water drop, or else mercury drops, all the drops are perfectly spherical. Why they are perfectly spherical? Because they are trying to have the minimum cross-sectional area with the help of one particular force, which you are calling it as surface tension. At the same time, suppose that if at all you are comparing the size of a bubble which is present in soap water and the size of a bubble which is present in plain water. Now whenever you are transferring, suppose that you are transferring a bucket of plain water, ordinary water, from one bucket to other bucket, you find some small bubbles in that. And when you transfer soap water from one bucket to other bucket, you find some big size bubbles. And you might have seen the kids playing with the soap bubbles. The moment you blow, you'll be finding a big size bubble like this. Now with ordinary water, with plain water, we cannot have that particular bubbles. We need to have certain amount of detergent powder to that one. We need to add certain amount of shampoo to that one. The different things. The moment you're adding, you're able to get some bubbles, right? The size of a soap bubble, increases. Why it increases? Because of low surface tension. The size of a soap bubble can be increased by reducing the surface tension of that particular liquid, right? So soap bubbles are bigger in size. Why? Because of low surface tension. Ordinary bubbles which are present in ordinary plain water, the size is not that much big, maybe around 1 centimeter, that's it. But after that it disappears. But wherein in the case of your soap bubble, in the case of your soap water, you find big size bubbles in that. You find big size bubbles. At the same time, you might have seen the case of mosquitoes. Wherever you find stagnated water, especially in the case of rainy season, right, immediately after 1 or 2 days, or wherever you find stagnated water, immediately after 1 or 2 days, you find some mosquitoes which are breeding on that one. The mosquitoes which are breeding on that. So the mosquitoes which take birth in that particular place, after taking birth, they just keep on moving on the surface of water. Mosquitoes and flies, they can easily move, they can easily walk on the surface of water, because the surface of water will behave like, the surface of water for mosquitoes will behave like a stretched membrane. The surface of water will behave like a stretched membrane for mosquitoes and flies, that makes walking easy for that particular mosquitoes or flies, as a result of which they can easily breed on the surface of water. They can easily breed on the surface of water. So this particular phenomena, why mosquitoes are able to breed, is because of surface tension. The moment the mosquitoes are walking there on that one, the surface tension of water is being minimized. So in order to kill that particular larva, the larva of those particular mosquitoes or flies, generally we add kerosene. The moment you are adding kerosene, right, the moment you are adding kerosene to water, mosquitoes will die. So there in that particular case, mosquitoes are dying because the mosquitoes will drown into that particular water and then they die. Right? So by the moment you are adding certain amount of kerosene, the mosquitoes can be easily, mosquitoes or flies can be easily eliminated. At the same time, you might have observed at your home number of times. So whenever you wash the cloth that we are using in the case of your kitchen, the cloth that we are using in the case of kitchen, or as the cloth that we are using as a doormats, right? So for cleaning that particular cloth, generally we use hot water. Generally we use hot water for washing the cloth that we are using in the kitchen, or else the case of your doormats. Now why we are using hot water? Because hot water has got less surface tension. The surface tension of hot water is less. So as a result of which, the dirt can be easily eliminated, the dirt can be easily removed. That is the reason why generally hot water is being preferred for washing of clothes. Hot water is generally preferred for washing of clothes. Now, so any particular water, right, as the temperature of water increases, surface tension of water decreases. Surface tension of water decreases. At the same time, you might have enjoyed the soup or tea or coffee. Now generally hot tea or coffee, whenever it is hot, it can be tea or else the case of your coffee, the tea or coffee, or else you can even say the soup. Now tea, coffee or else soup, as long as they are hot, they are tasty. Tea and coffee are very much tasty when they are hot because of low surface tension. Tea, coffee, maybe soup also. Tea, coffee and soup are tasty whenever they are hot because of low surface tension. At the same time, right, so whenever we are using detergent powder or else soap for washing of clothes. So detergent powder or soap is generally used for washing of clothes, because that particular substance which you are calling it as detergent or soap, it reduces the surface tension. The detergent powder or soap, it reduces surface tension, as a result of which dirt can be easily removed from the clothes. Right? That's it. This is about surface tension.